Okay, let's do a couple of problems. Let's look at number 2. Number 2, you want to solve using the substitution method. So you choose one equation and solve for x or y. Well, if you look, they've already solved for y in both these equations, which is great, because now you want to substitute one expression from that equation into the other. We could just substitute if y is equal to 3x and y is equal to 2x minus 4. We can take this 3x and just plug it in for y in our other equation, because it says y is equal to 3x. So now we're going to put 3x, we're going to take this down and put 3x is equal to, bring down the rest of your equation, 2x minus 4. We're going to solve for our variable, so we want to move that 2x over there with the 3x. Three x minus 2x is just 1x, so we can just put x is equal to negative 4. Well, if you start writing your ordered pair, it lets you know you're only halfway there, so you won't forget that you have another half. So what do you have to do with that negative 4? Yes, plug it into one of your original equations to find y. Well, this one's pretty straightforward, y equals 3x, so that might be the easiest one to plug into. So now in place of x, we're going to put our negative 4. So what's 3 times negative 4? Right, negative 12. It's a good idea to check yourself. 2 times negative 4 is negative 8. And negative 8 minus 4 is negative 12, which is what you want y to be. And then we need to check ourselves again. Y is equal to 3x. Well, we're saying x is negative 4. 3 times negative 4 is negative 12, and that is what y is. So we know that's correct. So that means that these two lines will cross at the ordered pair, negative 4, negative 12. So if we have these lines graphed, it looks like they both have a positive slope, then the point where they intersect is the solution, negative 4, negative 12. Okay? Okay, so that's the solution to that system of equations, and a system of equation has to have 2 or more equations. If you just have one equation, you don't have a system. Now let's look at number 3 and solve this system. Wonderful. We've already got y solved for. You can solve for x or y. In both of these equations we've solved for y, or they already have it solved. So in place of y, we're going to take a whole equation or a whole expression and plug it in for y into your other equation. Okay, so in place of y in the first equation, we're going to put 2x plus 2 is equal to, and you keep this the same, negative 2x plus 6. Now you have to solve, so I like to move my variables to the left, so I'm going to add 2x because I need inverse operations or opposites. They're gone. 2 plus 2 is 4, so we have 4x plus 2 is equal to 6. And now we're still solving for our variable x, so we're going to subtract 2 because we're going to undo that addition. And we have 4x is equal to 4. And what would you do at this point? Right, undo your multiplication by dividing. And we get our answer for x. X is equal to 1. But we're looking for an ordered pair, so we're only halfway there. What would you do with that 1? Yes, you can plug it into any equation up top, the first or the second. And I'll just choose to do the first. Y equals negative 2 times blank plus 6. In place of x, what should we put? 1, right? So now we're going to solve, let's see. Y is equal to negative 2 times 1 is negative 2 plus 6. Try to do as much as you can without your calculator, because you know you have a calculator inactive part on your test, so you want to make sure you're good at that. Negative 2 plus 6 is 4. So we're saying that our ordered pair 1, 4 is a solution. Now, like I said before, I can give you this ordered pair and ask you if it's a solution to the system. you would take for x and y and plug in and see. So I'm saying x equals 1. So negative 2 times 1 is negative 2, plus 6 is 4. That's what y is. So I know that's right, because that's what I want my y to be. So that looks good for the first equation. It has to work for both, because it has to be a solution to the whole system. So 2 times x would be 2 times 1. 2 times 1 is 2, and 2 plus 2 is 4. So I know that this is correct also. So we're saying that those two lines cross at the ordered pair 1, 4. We see one line has a negative slope, one line has a positive slope. The solution is where they cross is going to be the ordered pair 1, 4. Okay, let me do one more example with you. Let me find a really good example. And then I'm going to let you work on your own. Maybe in this one we should solve for x, so you can get an example solving for x. Let me erase some of that board. Let's do it over here. Looks like there's a good space over here. Okay. Okay, so we're going to call this number 3. We have y is equal to 2x minus 6, and x plus y is equal to 3. So I could actually go ahead and plug this equation in for y, or I could solve for x and then plug what I get in for x, or I could solve for y and plug it in. So you have options. Well, I guess since they already solved for y, I'll go ahead and do it that way. I wanted to solve one for x, but I think that might be easier. So you take this, they've already solved for y, so you put that in place of y, okay? So now we have x plus y is equal to this whole expression, so you're going to plug in that whole expression, 2x minus 6, and then bring down your equals 3. Because remember, you're plugging it into this equation, so you have to bring down the rest of that equation. So the idea is to just have one variable, so you won't, because you can't solve if you have two separate variables here. So 3x minus 6 is equal to 3, because we combine like terms. Now we can start moving things. We subtract that, well, it's a negative 6, so we're going to add 6. We're going to do the inverse operation. So 3x, good, they go away, is equal to 9. We have multiplication, so what should we do? Good, divide by 3, and we get x is equal to 3. So are we done? Nope, halfway there. So we have to take that 3 and do what? Good, plug it into one of your original equations. We can plug it right back here. So we're going to have y equals 2 times 3 minus 6. 2 times 3 is 6. So now we have 2 times 3 is 6 minus 6. So we have 0. So we have y equals 0. If you would like to see it like this, I can do that for you. So y equals 0. Let me make sure you can see that work. Yep, just made it. Let me know if you have any questions. That means if you graph these two lines, they'll cross at the ordered pair 3, 0, and that actually happens to be on the x-axis because you go over 3 and you don't go anywhere. Okay?